Hello class, this is a video tutorial on Calculus Part 1. In this video we'll be looking at secants as an average rate of change. Before anything new, we need to be familiar with gradients and what it represents. So I hope you remember that we can calculate the gradients as m equals the rise over run, and more specifically this little formula here. What that formula really calculates is this length of the rise and this length of the run. Okay? But more importantly, we need to understand that the gradient is a measure of the rate of change that a line is undergoing. Let's take a look at an example of this. So a gradient of 1 can be written as 1 over 1. Or 2 over 2. In any case, what this just really means is for every one run, or for every one across, the line goes up by 1 as well. Same goes for this one. A gradient of -2 can be written as -2 over 1. And what this means is for every one across, it goes down by 2. And lastly, a gradient of half can be written as 0.5 over 1. And what this means, for every one across, it goes up by half. Or we could have just left it as it is here. And what this means is for every 2 across, 1, 2, the line goes up by 1. In the context of a real-world scenario, we can really see that a gradient is a rate of change. So here are two graphs that represent, well, in this first one, it's tickets that cost $35 per person. If we have one person, it costs $35. If we have two people, it costs $70. Three people, it costs $105, and so on. So $35 is the rate per person. But also, if we were to measure the gradient of this line, it would come out to be 35. Same goes for this one. A water tank losing 10 liters per second. If it starts at 100 liters, after 2 seconds, it would have lost 20 liters, hence why there's only 80 liters left. And at 10 seconds, it would have lost, well, 10 liters per second times 10, that's 100 liters. Hence why it'll have from 100, it's going down all the way to 0 liters. And once again, if we measure the gradient of this line, it would come out to be -10 over 1. So a gradient is a rate of change. Now that we understand this, let's try and answer this question. What is the gradient, or what is the rate of change of a curve? This seems rather difficult to answer because there isn't a line that we can measure, is there? But as with math, we're going to build our understanding by first grasping secants. A secant is just a line that passes a curve at more than one point. So if we have the curve or the function y equals x squared, we can draw a secant any way we like. In this particular example, we draw a secant here and it crosses at these 2 points. For this function here, we can draw a secant that passes through 3 points. But we only focus on 2 points at any time. One last example. Here's a function, don't know what it is, but it passes through 2 points. By using the 2 points of intersection, we can calculate the gradient of that secant. Just know that the secant can be placed anywhere that we like, but the main thing that we'd like to understand is, can we calculate the gradient of that secant? Let's do 2 examples here. You can pause the video and give it a go yourself. Here we go. Let's calculate this gradient. The gradient is calculated as m equals y2 minus y1. That's going to be 4, take away 9, over 2, take away negative 3. That's negative 5 over 5. The gradient is negative 1. For this one here, same deal. Need the gradient, m. These points don't yet have a y value, but we can find them by substituting the x values into the function. So let's let this one be y2, and this y2 value is f of 1. So f of 1, because it's the height of this point when x equals 1, minus f of negative 2. And that f of negative 2 is just the y value at this point. For the x values, it's just 1, take away negative 2. Let's find these function values. F of 1 is 1 cubed plus 1. F of negative 2 is negative 2 cubed plus 1. So f of 1 is 2, take away negative 7, over 1 take away negative 2 is 3. Calculating this, 2 take away negative 7 over 3. So the gradient of that secant is 3. So we can calculate the gradient of a secant. This, however, is just the average rate of change between 2 points. To emphasize this idea, consider the following. The graph of a stationary car that accelerates for some time. So here's the car, it's stationary here. It's accelerating for some time, so it's getting steeper and steeper. It comes to a sudden stop, and then it waits for some time before driving back home. By calculating the average speed in the first 20 seconds, we calculate the gradients of the secant from x equals 0 to x equals 20. So let's do one more example of this. So we're looking at the secant from 0 to 20. So something like that. The function values here are x equals 20 and y equals 60. So you can go ahead, pause the video and calculate this one more time. So the gradient m is equal to y2, 60, take away y1 of 0, over 20, take away 0. That's x2 minus x1. Well, that's just 60 divided by 20. That's 3. So the rate of change that this car is moving is 3. Let's just say it's 3 meters per second. But as we've calculated above, in this example right here, the average rate of change, or the average speed, from x equals 0 to 20 is 3 meters, or 3 meters per second. So this means that the gradient of this line is 3 over 1. However, this makes the following assumptions. It makes the assumption that there is no stopping between x equals 0 and x equals 20. So this secant says the car is always moving and it's not stopping. The second assumption it makes is that the rate of change doesn't increase or decrease, meaning that the car is always moving and it's always moving at a rate of 3 meters per second, or whatever it might be. But we can see that the car isn't always moving. as it's stationary from x equals 15 to 25. So from x equals 15, it's already stopped, see? But yet the secant says it's still moving. We can also see that the average rate from 0 to 10, so if we were to draw as a secant from, let's do this in black, from 0 to 10, so this secant in black is less than the rate from 10 to 15. So let's draw this in. Let's take a look at this secant here in purple from 0 to 10, but we compare that to, say, 10 to 15. Notice how this secant is actually steeper. So the car is actually moving faster than 3 meters per second in between 0 and 20. So the secant is just calculating the average rate between 2 points. Okay, so since the secant measures the average rate between 2 points, the question remains, what is the gradient or the rate of change of a curve? We're going to build up to answering this key question by narrowing the question to what is the rate of change at a single point along the curve, as opposed to between any 2 points. So I'll see you in the next video as we continue to answer these questions. But for now, I hope you have learned about a secant and how to calculate the average rate of change between 2 given points. Hope to see you in the next video. Best of luck.